what to do in Lewis structure. What do we have to do first? What's the first thing you have to figure out before you can place anything? Yes. You make a count of your valence electrons. So, how many does hydrogen bring? 1. And there's 2 hydrogens. So there's your hydrogen. How about carbon? How many does carbon bring? 4. You're going to have to be able to look at a periodic table and do this. Oxygen brings 6. So when we do this, we can only place 12 electrons, but somehow this has to be surrounded by 8. This has to be surrounded by 8. These both have to be surrounded by 2 each. So, which element are you going to pick to be the central atom? Carbon. It's got the highest combining capacity. So it's in the middle. Now, what do you want to do? Do you want to place all 3 atoms around it? Or do you want to place 2 on it and then 1 on the end? Because this is how you figure them out. If you've got something that you've never seen before, you kind of got to play with it. What's your guess?
I would put all 3 of them on carbon.
All 3 of them on carbon. What is your reason? Why does your gut tell you to do that? You don't know? You just feel like it's so. Carbon wants to make 4 bonds. So the more atoms it has attached to it, the more likely you are to satisfy that rule. So if we put in our 3 atoms, we've used 6 electrons. 2 in each bond. So let's look at the terminal atoms first. So our outside atoms. So hydrogen, satisfied. Hydrogen, satisfied. Oxygen, not satisfied. Thank you. So, how many more electrons does that oxygen need? Well, right now, it's only got 2. So it's going to need another 6. Lucky for us, whoops, we have 6. 1, 2, 3, 4, 5, 6. So now, this oxygen is happy. What's that? Carbon's not happy. We've got no electrons left to place, but carbon's not happy because it's only got 6. Yes, we're going to double bond our carbon. So 2 of these were used to make the bond. So now, double check your structure. You should always check. When you do a quiz in math, you check your answers. Check your answer here. Count how many electrons have been placed total in your structure. Does it match the number of valence electrons? Once you've done that, check how many electrons are surrounding each atom. Do they have their octet satisfied? Oxygen surrounded by 8, carbon surrounded by 8, and each hydrogen surrounded by 2. We've used all of our electrons. We've satisfied everybody's combining capacity. Oxygen's got 2 bonds, carbon's got 4, hydrogen's got 1. So this is likely the best structure. Yeah.
do you do it in a triangle shape? Like how is carbon? Like, what if I did it like carbon and then
If you guys did it like this, I would accept that. That's fine, yeah. It actually does make the shape. It actually does make a triangle shape, but I'm not expecting you to know that. The only thing I'm going to make you do is what? When am I ever going to make you use shapes? What molecule? Water. That one I want the right shape. You don't have to make this like a trigonal planar shape. You just have to make sure you've got the bonds. Okay? So if you did this one down here, I would accept that. Okay? 4. Nitrogen. Okay, now we've got a problem. What did I tell you about electrons? The groupings of electrons. What did I tell you? Even numbers. Right? They're in pairs, 2s. You can't make a 2 into an odd number, like 9. That negative charge represents how many electrons? 1. So when you have a negative ion, you add an electron for every negative charge. If you had a positive charge, you would add them up and subtract for every positive charge that you had. So, cyanide. We've got 10 electrons. Got carbon. We have nitrogen. There's only 2. So, we've got 8 electrons left. Start putting them down. Where do you want to put them first, carbon or nitrogen? Which one would you think is your terminal atom? Which one is normally the central atom? Carbon is normally the central, so start with your nitrogen. If we put 6 there to satisfy its octet, we've only got 2 electrons left. So nitrogen's satisfied, carbon is not. What are you going to do? We can't add any more nitrogens. We've got what we've got. Make another bond between them by using a lone pair of electrons. That would give me 6 around carbon. This would give me 8. So now, how many electrons do we have? You've used 2, 4, 6, 8, 10 electrons. Is everybody's octet complete? So that is your best structure. Okay? If you have a negative charge, that means it lost an ion. And that ion is an atom with a positive charge. A lot of times what you've lost is an H+. A lot of your polyatomic ions, more than one atom forming a charge grouped together, a polyatomic ion, a lot of your polyatomic ions have lost hydrogen. Where do you think that hydrogen would have attached in your structure? Where do you think here your hydrogen would have been? Nitrogen likes to make how many bonds? 3. It's got 3 bonds. How many bonds does carbon like to make? 4. It's only got 3. So there's a good chance your H left from over there. So HCN that would have been the molecule to give you the cyanide. You would have lost the H+, it would have left its electron on the carbon to give you the cyanide. Most of the time, this is what has happened. Cyanide. You should put square brackets around it with a negative. Yes?
How do you know if it's polyatomic or not?
If it's a polyatomic ion, it has a charge. Right? A molecular compound won't have a charge as a superscript. Do you know? Subscript, superscript, right? You look up at the top. If there's a charge there.
Like the negative beside the N?
Yes, right? That is a charge, so that tells you this is not a molecule. It's an ion. So it's a polyatomic ion. Poly means more, atomic, more than one atom. Okay? It's a good question. You have to put square brackets and a plus or a negative if you're doing a polyatomic ion. I forgot to do this for cyanide. But you should. So, there's another method, and I only became familiar with this a few years ago when I had to make an answer key for my husband's class. He works at Brock, and he's a lab coordinator, and an assignment was given that he had to mark, and it's been eons since we were undergrads. So I made them for him, and they have this really neat method. Doesn't work all the time, but it works most of the time, called TVS. T is total wanted. V is valence electrons. And then S is shared. So all of these refer to electrons. So total electrons wanted. V, valence electrons. S, shared electrons. So, let's say I give you this. Okay, let's say I give you this structure. Total wanted. How many does carbon want total surrounding it? 8. How many does oxygen want total around it? 8. And there's 2 of them. How much does hydrogen want total around it? 2. And there's 2 of them. So what you're going to do is add up all of the total wanted. Am I right? 28? Okay, valence. How many does carbon bring? 4. How many does oxygen bring? And how much does hydrogen bring? 1 each. So, valence electrons is 18. To get the number of shared electrons, you subtract the number of valence electrons from the total. So this tells you that 10 electrons are shared, which means there's 5 bonds. So you're going to have a total of 5 sticks connecting your atoms, which sometimes can be really useful setting up the structural diagram before you throw in the extra electrons. So, knowing that you have 5 bonds, who's going to be at the center? Carbon. Who needs 2 bonds? Oxygen. So it's either going to be connected both like that, or it's going to be a variation of. Oops, that's supposed to be an O. If we do that, how many bonds have we used? 4. So that's not the structure. This gives oxygen 2 bonds. How else can you give oxygen 2 bonds? You can attach 2 different atoms to it, or you can attach 1 atom with 2 bonds. How many have we used now? Sorry, I'll move it up. How many bonds have we made? 4. But we still have a hydrogen. How many bonds currently are on carbon? 3. So let's stick the H on there. Another thing wrong with this structure is that carbon hasn't made 4 bonds. Carbon does not like lone pairs of electrons. You will see a lone pair on a cyanide and on a carbon monoxide. Anything else, it's got 4 bonds. I want you to remember that. Write it down. Put a star beside it. Carbon makes bonds. It doesn't like lone pairs. So now carbon's got 4, and we've used 5 bonds up. So if we've used up 10 electrons, go back to your valence electrons. How many do we have left to place? 8? But we've just used 10. Oops, sorry. Go back to your valence electrons. We had 18 valence electrons. We've just used up 10. How many do we have left? 8. So now you're going to put them around the atoms that don't have their octets complete. Oxygen. Oops. Right here. 1, 2, 3, 4. That one's finished. 1, 2, 3, 4. That one's finished. There you go. There's your structure. The benefit to TVS is it does tell you how many bonds are in your structure. And that's a good place to start. You throw your valence electrons on at the end.
Can you show us like an example of where it doesn't work?
It won't work on most polyatomic ions. Okay, so we're not going to use it there. And it won't work anytime you expand your octet. Okay, some atoms can expand their octet. TVS won't work for that. What do you think expanding your octet means? What does expand mean? Grow, bigger. So more than 8. If you look at this, sulfur hexafluoride, this is an actual compound. How many bonds does sulfur have in this structure? SF6. How many? It's got to make 6 bonds. 6 fluorines are attached to sulfur. That means it's surrounded by 12 electrons, which is more than 8. So here, SF6 has an expanded octet. It's surrounded by 6 fluorines. Fluorine will not expand its octet. Sulfur can. If you are on the 3rd period or below, you can expand your octet. TBS will not work for an expanded octet.
For all women below the 30.
So if you're on the 3rd, so phosphorus, sulfur, silicon, chlorine can expand their octet. They can be surrounded. Sometimes chlorine is a central atom. But they can all have more than 4 bonds around them. Okay? All right. I'm going